And again, here we are going to give another get pulses. And this get pulse is for T1. And here also we are providing another get pulses. So that get pulse is for T2. And in the negative half cycle, we are providing another get pulses, and that get pulses is for T1. So now, what will happen here is that we have omega T, and we are trying to get the output voltage. So this is my V naught. So until unless you are not providing any get pulses to T2, so T2 will not be turned on. So your output voltage, it should be 0. So from this point, your output voltage should be 0. And then when T2 is turned on, so T2 will behave like a short circuit. So if T2 behaves like a short circuit path like this, so the current will flow through T2 and come back like this. So in that case, your output waveform will be similar to your input waveform like this. So suppose we are considering this to be my alpha delay angle, and this is also 180 degree plus alpha. We are providing get pulses for T2 and T1. Then again, during the negative half cycle of the input waveform, what will happen? So during the negative half cycle, the polarities of the source, it will change like this, and current will try to flow in the opposite direction. So the current will try to flow in this direction through T1 and come back. But as long as we are not giving any pulses to T1, T1 cannot turn on. So in that case, your output would be 0 up to this point. And after that, when T1 turn on, then we will have the same output voltage like this. Is there any confusion regarding the waveform or the output waveform? Anyone?
No, sir.
Okay, that should be the output waveform. So in that case, if you want to get the average value of the output waveform, what should be the average value?
0.
Because since it is symmetric about the x-axis, so you know the average voltage, V naught average, it should be equals to 0. Now, if I want to get the RMS value of this waveform, then we can calculate that. So that should be your VRMS, and it should be 1 over, if I take the square of this term, so this square, it becomes positive, and this is negative. So if you take the square of this term, that should be positive 2. So we will be considering from here, this is alpha and this is 180 degree. So we can write it down as 1 over pi because it is 80 degree, and then it should be alpha to pi, and it should be Vm sine omega t whole square multiplied by d of omega t. So if I do that, it should be 1 over pi, then it should be alpha 2 pi, it should be Vm square sine square omega t multiplied by d of omega t. Okay, so if I take it down here, so that should be equals to 1 over pi. I take it 2 pi because we will take 2 multiplying here. So it should be Vm square. Since we are taking 2, so it should be alpha 2 pi 2 sine square omega t multiplied by d of omega t. So it should be then 1 over 2 pi Vm square 2 sine square theta is what?
Sir, 1 minus cos 2 theta.
Right. So it should be 1 minus cos 2 omega t multiplied by d of omega t, and the limit should be from alpha to pi. So now if I do the integration again, 1 over 2 pi multiplied by Vm square, and then it should be, if you integrate 1 with d omega t, it should be omega t minus cos omega t, it should be half sine omega t, and the limit should be pi to alpha. So now then it should be 1 over 2 pi multiplied by Vm square. And if you put that omega t, it should be pi minus alpha, and then half sine pi is what?
Sir,
0, right?
Sine pi is 0.
And then you have a minus term in the front, so it should be plus, and here should be 2 sine omega t, right? Then it should be half sine 2 alpha. Is there any confusion regarding this? Anyone?
No, sir.
So the rest of the people, they are sleeping, right?
No, sir.
No, sir. Rafi, sir.
Okay, so now that should be your VRMS, and that is the output VRMS, right? So now if I take Vm over 2, so it should be Vm over root 2. If I take it out, then the remaining value should be 1 over pi. Then it should be pi minus alpha plus half into sine 2 alpha. Vm over pi is the what? RMS value of the input signal, right? If I consider this to be my Vm sine omega t, then this Vm over root 2 is the RMS value of what? Input voltage, right? So that should be the RMS value of the input voltage multiplied by, it should be 1 over pi, then pi minus alpha plus 1 over 2 sine 2 alpha. So that is the very basic equation for a AC to AC controller. We are only considering we are just delaying some angle so that we can cut some of the portion of the AC signal to reduce the waveform RMS value. So whenever your alpha is zero, whenever your alpha is zero, what should be the value? So from 1, what we can get, if your alpha is 0, so this term becomes 0, and sine 2 alpha, it also becomes 0. So pi multiplied by 1 over pi, it should be 1. So in that case, your VRMS, V naught, it should be equals to what? Your VS.
Vm by root 2.
Yes, Vm over root 2, that should be the RMS value of the VS, right? Input voltage. And if you put alpha equals to pi, that is, you are delaying the firing angle by 180 degree, then what will happen? If you put alpha equals to pi, then this term will be 0, and sine 2 pi is also 0. So in that case, your VRMS output, it should be equals to 0. So in that case, by varying alpha, we can have the RMS value output AC signal. It can be varied from 0 to VS. You got my point, right?
Yes, sir.
So now, this is the very basic type of AC to AC controller circuit, but this circuit has some limitations. For example, if you remember my thyristor circuit, so this is my anode, this is my cathode, so this is positive, this is negative, and then we have to put a gate signal. So gate signal should be in between cathode and gate, and that should be plus and that should be minus as well. So you have to put a positive signal between cathode and gate. So to turn this thyristor on. Now, if we consider the previous circuit that we considered, here we have two thyristors connected anti-parallelly. So we have one thyristor connected like this, and we have another thyristor connected like this, and then it is connected to the load. Suppose this is V0. So now, if I want to make this upper thyristor turned on, what we'll have to do? We have to put a positive, negative signal like this. And again, we have another thyristor, and for turning it on, we need to put a positive, negative signal like this. So in that case, as you can see, their cathode is not common. For this two thyristor, suppose this is T2 and this is T1. So for T1 and T2, are their cathode is common?
So
No,
they are
sir.
opposite, sir.
So in that case, you have to have two separate circuit for providing gate pulses for T1 and T2. You cannot use a common driver circuit for turning T1 and T2 on. That is the limitation that this circuit has. Do you have any problem understanding what I am trying to say? Anyone? Since their cathode is not common, so we cannot use a common driver circuit for both of the thyristor. So how can we overcome these things? So we can modify this circuit with two thyristor connected to two diode. So suppose we have a circuit like this. We are considering a simple circuit. Suppose this is my source. And then we have two diode. And we have another diode. Suppose this is D2, this is D1. And in between we have another short circuit connection. And then we have thyristor T1. And then we have another thyristor connected like this. That is my T2. And then it is connected to the load. So what will happen? Suppose we are providing a positive signal like this. So in that case, if I draw the waveform, suppose this is a purely sinusoidal waveform. And we are providing a gate pulse here. Suppose this is my gate pulse. This is my input signal. That is my V in. And we are providing gate pulses here. This gate pulse is for T1. And this gate pulse is for T2. Now, tell me, when you are considering a positive half cycle, so your polarity is like this. And as soon as the thyristor T1 is turned on, what should be the direction of the current? So the current, it will try to go through T1, and then it will go through D1, and it will come back like this. You understand, right?
Yes, sir.
So the thyristor will operate now, and the current will flow like this. So in that case, it will activate as it is we were seeing in the for the previous cases. So here you will have the positive portion, and it will be working like this. Now, as soon as it is going to negative, so although this thyristor is not turning off because the current is flowing, but this diode will be turned off. And in that case, the whole circuit will be turned off until unless you provide a gate pulse for T2. And as soon as the gate pulse is given for T2, then what will happen? The polarities, it will be changing for the negative half cycle. So now the current, it will go in the opposite direction like this through T2 and then through D2, and it will return back like this. Any confusion regarding this? Again, if I want to see, it will go like this through T2, D2, and it will come back like this.
So diode cannot. Why did we take diode here?
Yeah, that's the thing why we choose diode instead of using two thyristor. The problem here for the previous circuit is that here we have two thyristor connected anti-parallel. For that, their cathode is not common. So we need to have two separate circuit for turning on two separate thyristor. But in this circuit, you have a common cathode terminal. So in that case, if you put a positive gate pulse here, this thyristor will turn on. And since the common cathode is here, if you put a positive gate pulse here, it will be turned on, right?
Okay. So to turning on these two at the same time, we just need to switch it on at their common cathode. So that is why we take this.
No, actually what we can do here, is that since these two thyristor has a common cathode, so what we can do here is that these two terminals, it can be combined together and we can provide a positive signal here. Because when it is positive and this is negative terminal, this thyristor, whenever you are putting a positive gate pulse with respect to cathode, this thyristor will be turned on and this thyristor will be in reverse bias, so it will not be turned on. But whenever you have the negative half cycle, then again if you put the common pulses plus and minus, then in that case this thyristor will be turned on, but the voltage across this thyristor will be negative, so in that case it will not be turned on. You got my point, right?
Okay. Yes, sir.
So in that case, in order to avoid two driver circuit for two separate thyristor, what we can do, we can add two extra diode and then we can have a common circuit for driving two thyristor at the same time. So in that way, we can avoid the problem regarding having two separate circuit for turning thyristor on. Is that clear for everyone? Any problem regarding this?
আর একবার একটু রিপিট করেন কেন দুইটা ডায়োড ইউজ করতেছি?
That is because here, as you can see, this thyristor has a cathode here. So that is your K1 and this is your cathode K2. So in order to turn this thyristor on, what you need to do, you need to provide a gate pulses with respect to the cathode. So if you want to make this thyristor T1 on, what you need to do, you need to provide a gate pulse positive G1 with respect to this cathode one. But is this cathode is same as the other one?
No, sir.
So in that case, you need to have another circuit that will provide a positive pulse to G2 with respect to K2 because they don't have the common cathode terminal. You got my point, right?
Yes, sir.
So how we can avoid that? We can avoid that by modifying this circuit to another circuit incorporating two thyristor and two yeah, so if one person who said that in that case, instead of using two thyristor, we can use track. Yeah, definitely you can use track. But if you have a thyristor and if you don't have any track, then you can not use these two thyristor with single driving circuit. You need to have modified this circuit in such a way so that you can have both thyristor connected to a common cathode, and then if you can provide a gate pulses there, so whichever thyristor is in forward bias, that thyristor will turn on and other will be turned off. So in that case, you can do the same thing, but with two added diode where you don't need to have an extra circuit for the thyristor. Of course, nowadays you have everything with the triac where you don't need to use the thyristor. But I am saying whether if you have the thyristor, then you have to have two separate circuits. Otherwise, you have to use two diode so that you can have a single driving circuit to turn on to thyristor. So in that case, now tell me, what should be the current waveform? What should be the current waveform?
Same as voltage waveform, but একটু কমে যাবে রেজিস্ট্যান্সের কারণে।
Right. Like this, right? That should be the waveform for the current. So your I RMS, I not RMS,
Sir,
it should be
square
equals to
waveform কেন হলো না? sine কেন?
What?
Current. So why isn't it a square waveform? Why is it like sine one?
Because the resistance, what is the relationship between the voltage and current for resistance?
Okay, sorry, I got it now.
So that should be the equation for the current, right? So you can see frequently questions, right? In your exam, sometimes it is asked as well that what is the problem of using two thyristor to provide a controlled AC output? And the problem is that you have to separate driving circuit for two thyristor when they are connected in anti-parallel. So how can you overcome this thing? By using two diode where they enable you to have two thyristor to have a common terminal, and you can use a single driver circuit to turn two thyristor based on the voltage polarities. So is there any confusion regarding this so far?
No, sir.
Okay. So now, so this is one type of AC to AC control circuit. Let us see another type of AC to AC controller circuit. So suppose now we have so I have already mentioned the book pages from the Neet Mohan's book and Harun Rashid book. So whatever is given there with the math example, I am just discussing about the theory. So if you understand the theory, I think your math calculation would be very easy for you, because if you know the equation, you can simply implement that and get the output. So in that case, so now if I want to get the power factor or other quantities for that, so can you tell me what would the input current? Suppose IS, it would be the same as I naught, right? Because the input current will only flow whenever you have the output current, right? Is there any confusion regarding this? Any confusion? Whenever your load will have the current, this current must be coming from your source, right? So in that case, what should be your RMS value of the input current? Since your input current is same as the output current, so that should be equals to your input current RMS as well. Right? Any confusion regarding this?
No, sir.
Okay. So now, if I want to see the power factor, so what should be your input power? Your P in, it should be V in phasor RMS value, then it should be IS RMS value, and then it should have the cos theta, where cos theta is the angle between what? V in and IS, right? And what should be your output power? What should be your output power? It should be V naught RMS whole square divided by R, right? Any confusion regarding this?
No, sir.
Okay. So now, in an idealistic case, whatever power you are putting in the circuit, if this is a lossless medium, then what will happen? Your output power will be exact same as the input power, right? So in that case, what should be? We can write your P in, it should be equals to your P out, meaning your V in RMS multiplied by IS multiplied by cos theta, that should be equals to your V naught RMS square over R. Or we can write cos theta, that should be equals to it should be V naught RMS square over R divided by V in multiplied by IS. So we can write it down as V naught RMS square over R. That should be your V in RMS. And what is my IS? IS is the same as V naught RMS over R, right? Any question regarding this? So if I cancel this down, it should be V naught simply RMS and RR will cancel out. So we can write your cos theta, that should be equals to V naught RMS over V in. So what was my V naught RMS? We derived that equation previously, right? This one. So it should be then, that time we wrote Vs, but now we are deriving it as a V in. So we can write it out V in over, what was the value? 1 over pi. Then it was pi minus alpha plus half into sine 2 alpha divided by V in. So if you will cancel out, so what should be the input power factor then? It should be the square root of 1 over pi, then pi minus alpha plus half into sine 2 alpha. Is there any confusion regarding this? Anyone?
No, sir.
Okay. So now another way of achieving a controllable output AC signal is that by forcing on-off control. So on-off control, what is that? We'll see that in a little bit of time. So suppose you have a voltage source, that is your Vs, and now we are simply implementing another anti-parallel thyristor circuit like this, T1 and T2. And then we have a simple resistive load. Suppose this is V naught. Now your input signal here, Vs, it has sine wave. So now we are dividing this sine wave into two half. Suppose this is your M cycle for which your thyristor T1 and T2, it will be turned on. And then there is another half. Suppose let me take it like this. So that is another half for which T1 and T2, it will be turned off. So during that portion, M cycle, T1 and T2 will be on. And for N cycle, T1 and T2 will be off. So now, if I draw the circuit, and for this case, we are considering the alpha, that is my delay angle, is 0. So we are not putting any delay pulses for T1 and T2, but we will make sure for some cycle T1 and T2 will be turned on, and for the rest of the cycle T1 and T2 will be off. So as you can see, if I draw the output waveform, suppose this is my output waveform. So during that portion, T1 is on. Sorry, the positive half cycle T2 is on, and this portion T1 will be on. For this portion, T2 will be on, and for this portion, T1 will be on. So in that case, what will happen? Your output will be exact the same as it is for the input waveform. Do I need to explain the operation?
Sir, where is the gate pulse?
We are not there. Gate pulse is there for two separate circuits. For this one, it is this is my K1, and suppose we are providing a gate pulse here, so that is my G1, and we are providing a plus minus gate pulse here. Similarly, for this one, we have another circuit, and that should be your plus minus. So that is K2, and that is your G2. And here we are providing gate pulses here at the starting of each cycle. So here we are providing gate pulse. Again, here we are providing gate pulse. And here we are providing gate pulse. For this gate pulse is given to T2. This gate pulse is given to T1. This gate pulse is again given to T2. And gate pulse is given to T1. Any confusion now?
No, sir.
And for the remaining portion, we didn't provide any gate pulses. That's why T1 and T2, it will not be turned on. So now, tell me, what should be the average value of this waveform?
Sir, 0.
It is 0, right? Because whenever you have waveform that has the positive half, that should be equals to the negative half. So that it will cancel out, and during this portion, the value is also 0. So if you combine them together, your average value would be 0, right?
Sir,
Tell
another
me.
reason. Sir, here we have considered even number of lambda by 2. That is why we are getting 0. But let's say if we had odd number of lambda by 2, where
Yeah, in
yes,
that case, it will not be 0.
not be 0, yes.
But if you do that, you can do that. But the common practice is that if you take the waveform or that turning it T1 and T2 on, you will turn it for the complete cycle, not for the half cycle. Okay.
Okay.
Now, what should be your then RMS value of this waveform? what should be the RMS value of this waveform? So for this one, we need to calculate the total area, right? For which thyristor is turned on and thyristor is not turned on. So what should be the total length of time then? So this is M cycle. So this area, it should be M multiplied by 2 pi, right? And this is turned off for N cycle. So this area is N multiplied by 2 pi. So what should be the total area then?
স্যার এখানে n মাল্টিপ্লাই বাই 2 পাই হবে না তো, এখানে তো তিনটা ল্যামডা বাই 2 আছে স্যার, তাহলে ওটা একটু এক্সটেন্ড করে নিতে হবে।
Okay, so now up to this point, you consider it to be N, okay? Now is it okay?
Yes, sir.
Okay. So the total area, it should be M plus N multiplied by 2 pi, right? So if I divide it, whenever we are taking a VRMS, what we do 1 over the total area. Total area is what? M plus N multiplied by 2 pi. So what should be the area for which it is turned on? It should be M multiplied by
2 পাই।
So it should be what? Multiplied by M multiplied by
2 পাই।
Okay. Now tell me, if we consider only one cycle, so that should be your 2 pi, right? So here it should be M multiplied by 2 pi. So that area, we are taking it from here to here, right? Now, if I do the integration, so it should be from 0 to pi. So it should be 0 to pi, then Vm square sine square omega t multiplied by d of omega t. And now this cycle, this is area, right? So how much area we have within M cycle? M multiplied by 2, right?
স্যার একটু রিপিট করা যাবে লাস্ট পার্ট?
Yeah. If we have a sine wave, so this is 0 to pi and this is 2 pi, right?
Yes, sir.
So if you take the area and if you square that this term, this is positive, and for the negative portion, if you square that, that should be also positive, right?
Yes.
So now if we integrate that 0 to pi, so we are taking the positive half, but this is happening
For
twice
two.
within the 2 pi period, right?
Yes, sir.
So here we should multiply it by
2.
make sense?
Yes, sir.
Any confusion regarding this? Okay. So if I cancel it out, then we can write m over m plus n multiplied by 0 to pi. That should be equals to 2 sine square. It should be Vm square. Then it should be 2 sine square theta. So it should be 1 minus cos 2 omega t multiplied by d of omega t. So now,
স্যার একটা কনফিউশন আছে
yeah, sure, tell me.
স্যার T1 আর T2 কত সময় অন ছিল? m ইন্টু 4 পাই সময় অন ছিল না?
Which one?
T1 and T2 কত
Mhm.
সময় অন ছিল স্যার? এটা 4 পাই পর্যন্ত অন ছিল না, 4 পাই টাইম পর্যন্ত না, 2 পাই আর 2 পাই দুইটা সাইকেল অন ছিল তো।
Hmm. So
তাহলে
we
m
just
ইন্টু
in
4 পাই,
figure we are showing it to be 4 pi, but it can be generalized to any number of cycles, right?
ইয়েস স্যার।
So that's why we are defining it with m and n.
ও
You got
এবার
my
বুঝতে
point?
পারছি স্যার। জি স্যার, জি স্যার।
So now here, what we do should be the equation for that one.
Sir, omega t minus sine 2 of omega t divided by 2. মানে ইন্টিগ্রেশনের ভিতরে
M over m plus n multiplied by Vm square, and then it should be
omega
omega t
minus half
minus half
sine
sine 2 omega t,
0 to
and the
pi.
limit should be pi to 0. Right? Okay, so for
Yes,
the
sir.
sine wave, when we do the RMS value, how can we write that? We write 1 over pi, right? Right? And
Sure.
if we say 1 over 2 pi, then what we can do, this is the total area that we have. And then we limit it from
0
0
থেকে
to
2 পাই
pi,
স্যার। ও
0
0 থেকে
to
পাই স্যার।
pi, and then it should be 2 Vm square sine square omega t multiplied by d of omega t, right? Right?
ইয়েস স্যার।
So what was my total area during this portion? The total area was m plus n multiplied by 2 pi, right? Right?
ইয়েস স্যার।
So Doing that, if we calculate that, should we have 2 pi here? By comparing these two equations,
Sir, 4 pi হবে স্যার?
it should be 2m, right? If this is one cycle, how many cycle of this we have? 2 multiplied by 1, right? If this is one cycle, why we are multiplying it by 2?
Because we have 2 cycle.
2 cycle within one cycle, right?
Yes, sir.
So now tell me how many cycles we have here? M cycles, right? So it should be 2 multiplied by m, right? Not multiplied by 2 pi.
Yes, sir.
You got my point?
Yes, sir.
Is there any confusion?
এই পার্টটা একবার একটু রিপিট করেন।
Suppose you have 2 cycle, okay? So now if you write it down 1 over 4 pi. If you write it down 1 over 4 pi, 1 over 4 pi, and then you are doing that 0 to pi, so 0 to pi, and then Vm square sine square omega t multiplied by d of omega t. So now, how many of this you will have within the cycle?
4
4. How you can go that? 2 cycle multiplied by 2 of each cycle, right?
yes sir.
So similar way, this is the total area under the wave, right?
Yes sir.
So what is the total area under this wave?
M plus n into 2 pi.
M plus n into 2 pi, right?
2 pi. Yes sir.
But above, should I multiply it m into 2 pi, or we just multiply 2m?
2m স্যার। n তো n সময় তো আমি কোনো পালস পাই নাই আউটপুট।
So it should be simply multiplied by m into 2, right? 2m.
yes sir.
You got my
Yes, sir.
point now?
yes sir. yes sir. thank you.
So it should be simply 2 pi. And here it should have 1 over 2 pi. And here also you should have 1 over 2 pi. Now, if I do the integration now, so it should be m over m plus n 1 over 2 pi multiplied by Vm square, and this should be pi minus 0, and then sine pi is also 0, sine 0 is also 0. So we can write it down as m over m plus n, and then it should have 1 over 2 pi multiplied by Vm square multiplied by pi. So this pi will cancel out. So what is, if I take Vm over 2 out, it should be Vm over root 2. And then you have m plus n. What is Vm over root 2? What is Vm over root 2? That is the RMS
Yes.
value of the input waveform, right?
Yes.
So we can write it down as Vs RMS multiplied by m over m plus n. So what should be the ratio then? V naught RMS, output RMS over input RMS. That should be the ratio of what? M divided by n plus n. So that is also known as the duty cycle. Because if we consider the total area to be one cycle, then of which your m times is on and the remaining time is off, So in that way, we can consider it to be the duty cycle, what we discussed for the DC to DC converter. You got my point, right? So similar way, if I redraw this circuit here, so now whenever you have the output current, that current should come through your input current, right? So your output current RMS value, I naught RMS value, it should be equals to IS RMS value, right?
Yes, sir.
So in that case, what should be your output, since we are considering it to be a lossless circuit, so your input power, it should be equals to your output power. So we can write your input power is Vs RMS multiplied by Is RMS multiplied by cos theta. It should be equals to your output RMS. Your output RMS is what? V naught RMS square over R. Right? Any question regarding this? So what should be, or in that case, we can write it down as V naught RMS multiplied by V naught RMS over R, or we can write it down as V naught RMS multiplied by I naught RMS. So your I naught and IS RMS is the same. So we can write it down as cos theta, that is the input power factor. It is nothing but your V naught RMS over Vs RMS, which is nothing but this ratio. Any confusion regarding this? Anyone? Do I need to clarify anything? So now we will be doing one math problem, that is your example 17.1. It is says, suppose we have a regulator that we considered. So this is that regulator where we have one thyristor. Suppose we are considering this to be my T1, and this is my another thyristor, that is my T2, and both are connected to a resistive load. And it says that this resistance value is given as 5 ohm. And input source voltage is given as 220 volt RMS, and frequency is 50 hertz. And it says the thyristor is switched on for 20 cycles. So M is what? 20 cycles. And it is turned off for 60 cycles. So if we redraw the waveform, suppose this is my omega t, we are having some sine wave and it is continued. And then again, we have another sine wave like this. So it says it is turned on up to how many cycles? 20 cycles. And it is turned off for how many cycles? 60 cycles. So in that case, this is my source. So what should be my output waveform? So your output waveform will be exact as the input waveform for first 20 cycles. Then it will be turned off like this. So during the positive half cycle, here T1 will be turned on, here T2 will be turned on, again here T1 will be turned on, T2 will be turned on, T1 will be turned on, T2 will be turned on. And since this is a resistive load, so this is your V naught. And what should be your I naught? I naught should be the same thing, the output voltage, but it would be reduced by the amount resistance, right? So your output current will be like this. So that should be your output current. Now, they are saying that you have to calculate, find the output voltage. First, you have to calculate the output voltage. Output voltage. V naught RMS. So what should be the V naught RMS then? It should be Vs multiplied by what? M over M plus N, right? So what should be your V? 220 multiplied by what is your M? 20 divided by 20 plus 60. So what should be your RMS value? What should be the RMS value?
110
What?
110 ভোল্ট
110
Right? Now,
Yes, sir.
second point, they wanted to have. Okay, so before that, what should be your I naught RMS then? It should be V naught RMS divided by 5 ohm, right? So 110 divided by 5, it should be 22 amps, right? Make sense? Any confusion?
No, sir.
Now, the second thing they wanted to see, thyristor average current. I thyristor average. How can we do that? Now, this portion, it is coming from T1. Again, this is T1. This is T1. Right? So what should be the thyristor average current? Is it 0 or is it positive?
স্যার একটু রিপিট করবেন কোয়েশ্চেনটা?
Yeah, we need to calculate the thyristor average current, right?
ইয়েস স্যার।
So I naught RMS is 22 amps. Okay. So now tell me, if I draw the thyristor current here,
থাইরিস্টর কারেন্ট ইনপুট কারেন্ট বা আউটপুট কারেন্টের সমানই হবে না?
IT1, suppose we are calculating thyristor current. So the thyristor current will be what? During the positive current, this way, right?
ইয়েস স্যার।
So the thyristor current should be like this.
ইয়েস।
That should be T1, right?
ওকে, ইয়া।
And what should be your T2? It should be like this, right? That should be your T2. These two combine to get the output current, right?
ইয়েস।
So now tell me, what should be the thyristor current then?
Sir, it will be a positive value for T1.
Yeah, but tell me, suppose this is my M, this is my N. So what should be the total area during this period? It should be 1 over M plus N total area. So this total area is what? M plus N multiplied by 2 pi, right?
Yes.
Right?
Yes, sir.
Now, this is one cycle. So it should be what? 0 to pi. Then it should be Im sine omega t multiplied by d of omega t. And how many times it will happen? How many times it will happen?
20.
20. That means you have to multiply it with M, right?
Yes.
You got my point?
Yes, sir.
So it should be M over M plus N multiplied by 1 over 2 pi. And then if I consider this is my Imax, so if you do the calculation here, you will get Imax over pi, right? If you do that, sine omega t is what? Minus cos omega t, right?
Yes, sir.
So if you do the integration, you will get this value. So now you know everything. So your M is 20 divided by, it should be 20 plus 60.
1 by 2 pi.
1 by 2 pi. And what should be your maximum value? Maximum value should be RMS value multiplied by
√2.
√2, right? So it should be 20 multiplied by √2 divided by pi.
Pi. Yes, sir.
So what should be that value? Sorry, I might made a mistake here. So can you do the integration by yourself? So it should be Im sine omega t multiplied by d of omega t. If you integrate that one between 0 to pi, what should be the value? And if I take Im out, it should be minus cos omega t, and it should be pi to 0. So it should be Im cos pi is -1, right? So minus minus, it should be what?
Im value আসবে স্যার। মনে স্যার।
So it should be minus cos pi plus cos 0 degree, right? So cos pi is -1 minus minus, it would be plus,
So 2I, sir, 2I.
it would be 2 Im, right? So here it should be not Im over pi, it should be 2 Im, right? So these two will cancel out. So it should be Im over pi. So Im is what? 22 multiplied by √2 divided by pi. So what should be this value?
Point 47.
0.47
So
amps. Right?
2.47, sir.
Okay, 2.47. Okay. And again, if you want to get the RMS value of this current, what would be your RMS value?
স্যার থাইরিস্টর এভারেজ কারেন্ট যে বের করলাম এটা কোন থাইরিস্টরের
It would be the
Done.
same, right? Because for the thyristor one, this direction is considered as positive. For thyristor 2, this direction is considered as positive, right?
ইয়েস
So their value would be same, but their direction
Yes,
would be different.
ওকে স্যার ওকে
You got my point, right? Because whenever you are
Yes.
taking a square, this negative value, it would be positive, right?
ইয়েস স্যার
Now, what should be the thyristor current average RMS value? It should be the same thing, but it would be in the square root of that, right? So it should be m over m plus n multiplied by 2 pi. That should be the total area. And then it should be 0 to pi. And then it should be Im square sine square omega t multiplied by d of omega t. And then you have to calculate that one. You'll be able to do that, right?
Yes, sir, পারবো।
And the last thing, what should be the power factor? What was the power factor that we derived? This one, right? So it should be m over m plus n. So it should be 20 over 20 plus 60. So that should give you
0.5
0.5 lagging, right?
স্যার ল্যাগিংটা কেন হলো
Why?
স্যার ল্যাগিংটা কেন হলো ইন্ডাকটিভ লোডের কারণে নাকি
No, it is resistive load, right? But why we are considering
sir.
it to be lagging? Because if you do the harmonic analysis of this waveform, is it purely sinusoidal? Your output? Here you can see your output, right? Is it purely sinusoidal for the entire period?
নো স্যার
So if you do the Fourier analysis, will you get the only the fundamental components, or it will have the higher frequency components as well?
স্যার ভি আউটপুট তো এম পর্যন্ত সাইনোসয়েডাল।
Yeah, but for the if you do the Fourier analysis, you will find that your fundamental components, your output waveform will not have only the fundamental components, rather it will have fundamental components and the high frequency components as well. So that's why this overall power factor, since it has the higher frequency components as well, there should be a displacement factor, harmonic factor and other things as well, for which your power factor will not be purely resistive, or power factor should not be purely 1. Rather, it will behave like a inductive load.
Okay, sir.
So should I continue further? Okay, so basically the topic that we have covered here, it is taken from 2 books, Harun Rashid and the Needmon's book. So Needmon's book, the edition that I have given you, that doesn't contain these pages. So I will scan that new book and I will send that to you, hopefully by tonight. So you will go through these pages to see how things work. We have discussed the things here. And based on that, there will be questions given in your final exam. And as I said in the class, there would be one set of questions from the AC controller and that might have some explanatory things, and that will have some mathematics as well. So you need to have a clear conception about the output waveform, how to calculate your RMS value, output average value, and the currents waveform, so that you can calculate the average or the RMS value and calculate the power factor as well. So that is basically the end of today's class and the class with you. So best of luck for the final exam. And if you have any question, you
Question
can ask
pattern,
me.
স্যার কোয়েশ্চেন প্যাটার্নটা একটু বলবেন?
As I said, there will be 6 sets of questions. So from these 6 sets of question, 1 will be from DC to DC converter, including Chook, Sepik, and flyback. There will be a theory question regarding this, and as well as the math. And then 1 set of question will be from DC to AC converter, which is basically known as inverter circuit. So for the inverter, we discussed about half bridge, full bridge, 180-degree conduction, 120-degree conduction, sine PWM, application of this inverter, like the induction heating. So based on that, this theory, for each and every inverter, you have to know the output waveform Fourier analysis, and question will be given based on that. And then 1 set of question will be from AC to AC controller. That is basically during the content will be inside this page limit. So if you go through all the pages there, you'll be able to answer that question. And the rest 3 sets of questions will be from your uncontrolled and controlled rectifier. Both single phase and 3 phase. That we have covered after the midterm exam. So that is basically the 6 sets questions. And if you want to do, we can do some recap class before the final exam as well, that we did after the midterm exam.
স্যার একটা সলিউশন ক্লাস নিলে ভালো হয় স্যার, প্রবলেমের সলিউশন ক্লাস।
স্যার মানে আমাদের যদি কোনো সমস্যা থাকে সেটা যেন আপনাকে বলতে পারি, এরকম টাইপের।
Okay, I can do that.
যেমন স্যার এই যে চুক, সেপিক আর ফ্লাই ব্যাক স্যার, এটার উপর 1-2টা ক্লাস নিলে একটু ভালো হয়।
I have given so many lectures on that.
তাও স্যার একটা রিভিশন ক্লাস হলে ভালো হতো স্যার।
Okay, if you find it difficult, let the CR know me, call me, and I will try to have a recap class based on your request. But before that, I have to inform which are the topics that I need to include, because this is the first time I'm taking this power electronics course and I don't remember each and everything. So, okay, that's ends our class here. If I take any further classes in IoT, hopefully we'll meet. Otherwise, if I anyway hurt you, don't remember that. And I wish you best of luck in your life. And please do dua for me. Okay.
জি স্যার, ইনশাল্লাহ স্যার।
Okay. Assalamu alaikum everyone. Allah Hafiz.
ইনশাআল্লাহ।
ওয়ালাইকুম আসসালাম। ওয়ালাইকুম আসসালাম।
ওয়ালাইকুম
আসসালামু আলাইকুম।
আসসালাম।